Now we're going to talk about dividing polynomials, and not in the rational expression way that we've been doing up to now, but true long division of polynomials. And I say long division because that's exactly what we're doing. This division that we're going to do now looks exactly like the long division you were doing back in 5th grade. Let's look at an example. An easy example is something like 3x squared into, I don't mean to make this look like a radical sign, right? This is a division sign. So 3x squared into 9x cubed minus 6x squared plus 15x. Let me just pull this down a little bit. Okay. And this is fairly simple. 3x squared goes into 9x cubed 3x times. 3x squared goes into negative 6x squared 2 times, negative 2 times. 3x squared goes into 15x. Well, this one's a little bit weird. Let's look at what this would look like if we were simplifying it as a rational expression. The 3 and the 15 would result in 5. The x and the x squared would actually result in x to the negative first power, or we could write it as 5 over x. And that's what we're going to do. So this long division is pretty straightforward, right? We don't have any of the subtraction going on down here. We just have 3x into each one of these terms, and there's our result. But what if we have more than just a monomial that we want to divide? Let's look at a polynomial or a binomial into a polynomial. So the problem is set up this way. Three x squared minus 4x plus 13 all divided by d plus 3. So we want to set that up just like we set the other one. D plus 3 into 3x squared. Oh, sorry, not d. I want to use the variable x. Sorry, x plus 3. So 3x squared minus 4x plus 13. Well, it's hard to sort of determine how does x plus 3 go into each one of these things. So what we look at is we look at just this first part here, just the x. The x goes into 3x squared 3x times. And then you do multiplication. You do 3x times x, that's 3x squared. 3x times 3, that's 9x. And then we subtract that amount from what we have here. The 3x squareds cancel out. That's the idea. They're supposed to. Negative 4 and 9 leave us with 5x. And then we bring down, the negative 4 and 9, actually, because we're subtracting the 9x, that's going to give us 13x. So negative 4x minus 9x is negative 13x. And then we're going to bring down the positive 13. Okay. Now we say, how many times does x go into negative 13x? Well, it goes in negative 13 times. Negative 13 times x is negative 13x. Negative 13 times 3 is negative 39. And we do our subtraction again. The first terms cancel out. Now we have 13 minus negative 39, so plus 39, giving us 52. That's sort of like a remainder. And the way we deal with remainders in this case is we just put them on the end. as a rational expression, the remainder divided by what we were dividing by, right, like that. So your final answer for this problem would be 3x minus 13 plus 52 over x plus 3. And that's your final answer. So it's a lot like long division, except what you're considering is just this first term when you do the initial division. Then you do multiplication with both terms, and then you do subtraction. And then you bring down and start the process again. Let's look at another example problem. Three x minus 1 into 18x cubed minus 8x plus 2. Okay, so we start off 3x. How many times does 3x go into 18x cubed? It goes in 6x squared times 6 times 3x. 6x squared times 3x is 18x cubed. 6x squared times negative 1 is negative 6x squared. And we're going to do subtraction. Now, notice these two terms are not like, so I can't subtract them from each other. So I have to consider in here there's this 0 term, right? I have to imagine this is actually more like 18x cubed plus 0x squared minus 8x plus 2. Adding in this plus 0x squared would allow me to have something to take this away from. So the first two terms cancel out. And if I imagine this 0x squared term here and I'm taking away a negative version of this, I end up with positive 6x squared minus 8x in the bring down, right? I'm bringing that down there. So this term, again, is getting subtracted from a term in here that's not written, and it looks like this. It's this term, 0x squared. All right, now 3x into 6x squared is 2x, so plus 2x. 2x times 3x is 6x squared. 2x times negative 1 is negative 2x. Do my subtraction. I end up with negative 6x plus 2, bringing this down. Okay. 3x goes into negative 6x negative 2 times. Negative 2 times 3x is negative 6x. Negative 2 times negative 1 is positive 2. If I do my subtraction, everything cancels out to 0. And this here is my final answer. So it's a lot like the long division. The only thing to remember is that we're not dealing with this whole binomial. We're really only dealing with this first term here. And we're seeing how many times does this first term go into each thing. Then we're doing multiplication. Then we're doing subtraction. Then we're bringing down. Then we're starting the process again. And that's long division with polynomials.